Now, functions can be categorized into two kinds: useful functions and harmful functions. Useful functions changes the parameters of the object of the function in a desired direction. For example, in yesterday's office hours, we were discussing the problem of that due to this online e-commerce, local shops are suffering. So we were thinking of a solution where the local shops would get more footfall or would get more orders, and they will be able to recover their loss of income. So that would be the useful function. Now, there could be other parameters, or there could be other components in the super system or in the system which could lead to worsening the parameters of the object of the function. Those functions are called harmful functions. For example, we could say that Blinkit, for example, has some harmful function for the local vendors here. Or Swiggy would have some harmful function. Swiggy, Instamart would have some harmful function for the local vendors there. But the solution that we are providing is providing useful functions. It is taking care of, it is removing the harmful functions that Blinkit has. It is removing the harmful function that Swiggy, Instamart has. So it is important to understand what are the harmful functions in an engineering system also, so that overall efficiency of the system can be enhanced. So functions are categorized as useful functions and harmful functions. In the case of a toothbrush, useful functions could be like bristles distribute toothpaste, bristles remove food, bristles remove plaque, and harmful function could be bristles damage gums. So if we can have a toothbrush which would do just these two things and not this, it would be a better toothbrush. Is it not? Hello?
Yes, sir.
Yes, sir.
Yeah. So it is important to categorize functions as useful functions and harmful functions. Now, useful functions are also further categorized into a zone where we talk about how effective those functions are. So you wanted a system to do a component to do some useful function. It could happen that it is doing that useful functions a bit too much, excessive, or it is not able to do the function at the required level of performance. So it is insufficient, and then it could be normal. So excessive and insufficient levels of performance are disadvantages in the engineering system. Now, if you come to think of it, excessive performance of a function sounds to be good. When do you think it is not good?
When the thing becomes uncontrollable.
Okay. Yes. Can you give an example, Devjit?
Let's say a circuit level example only. So let's say we are having a big NMOS which is leaking. So if we are not able to control that leakage at FF125, it would leak at a very high rate.
So Devjit, leakage is a harmful function. We are not categorizing harmful functions at all.
So for example, a braking system can stop the car very quickly, like instantly. So that can hamper the driver.
Very good. Yes. A braking function stops the car instantly. So you can actually, a passenger can actually hit the dashboard. Or the car was moving and the movement it performed excessively. So it was supposed to stop somewhere. It moved excessively, did not stop there. Or you were rubbing a surface to clean it. You performed the function excessively such that the paint also got removed. So excessive performance of a function is also not good. It could lead to situations which you do not want to happen. Then you have to correct it. आपको वापस पेंट करना पड़ेगा, आपको वापस पॉलिश करना पड़ेगा. So excessive performance of a function is not desired. Insufficient performance of a function is definitely not desired. I think that is intuitive enough. Huh? We always want normal. At times, excessive performance of a function may not lead to any immediate harm. In fact, could be desirable, but it is not something which is leading to any profit, additional profit also. So you would say, let me save costs, because in performing this function in an excessive manner, I am incurring some extra cost. So let me save cost. So again, it is undesirable. Okay. So once you have labeled functions as excessive or normal or insufficient, another ranking or a ranking of the functions is also desired. A function which is directed on the target is a basic function, and it is assigned the highest rank 3. Let us say 3 points. Function directed at any other supersystem component is an additional function. Again, engineering system का main function नहीं होगा वो शायद, but it is still an important function because it is acting on the supersystem. It is called as an additional function. It is assigned 2 points. A function directed at a component of the engineering system itself is an auxiliary function and assigned only 1 point. Do you remember we made a chart of value where we said that sigma of functions upon sigma of costs, and we said that more functions and lower cost is high value. You remember this? We wanted to be in this quadrant.
Yes, sir.
So this ranking, this giving some points to different functions is being done so that we can place different components in these quadrants. So if a particular component is involved in a basic function and 2 additional functions, we would say the sigma of function is 7. If it is involved in just one auxiliary function, then the sigma of function is 1. So it would lie somewhere here. Now, depending on the cost, it could be in this quadrant or in this quadrant. This one would probably lie somewhere here. Depending on the cost, it could be in this quadrant or in this quadrant. But this ranking is being done so that we can assign some value to the function, to the components of the engineering system. How we will use it, we will see later. But it is to place components on this matrix. What is the value that any particular component of my engineering system is bringing on the table? So, any questions till now, or we look at an example and then wait for questions? Anything that is not clear yet? Okay, so let's look at an example, and probably if there is anything which is not fully clear yet, you will be able to see what you will be able to get more clarity there. Let's look at a toothbrush. A toothbrush has parts. So what all could be a part of the engineering system over here? How would you define the engineering system over here? Which components are a part of the engineering system and which components are a part of super system? Quickly.
So all the parts that are associated with the brush, because the handle, the rubbing part, and the base part, where that is the engineering system.
So we are saying this is the engineering system.
Yes.
And the remaining is super system?
Yes.
Okay. Anyone else and any other ideas around this? Okay. So we now know what is the engineering system, what are the super system components. So now we start to plot the functions there. Hand moves handle. Hand holds handle. Handle holds the head and moves the head. Head holds and moves the bristles. Bristles distribute paste. Bristles remove plaque. Toothpaste removes plaque. The handle informs the person that the tooth, like what is the progress in terms of brushing the teeth. So all these functions are happening in this engineering system. Should we start to rank them now? So let us say, what rank would you give to the function that handle is performing on the head? What is the total function addition that the handle has? Quickly, what are the functions that the handle does?
The informs can be an additional function.
Okay, so what is the target for you?
The teeth.
Okay, target are not teeth. Target are plaque.
Oh,
Removal of plaques. Yes, yes.
You do not do it. It does not do anything to the teeth, huh?
Yes.
So the target is plaque and other food or whatever. And then the person itself is the another super system component, and you are informing. So okay, you say informs is the additional function. What about holds and moves?
That can be the basic function.
Hold and move are basic functions. What is a basic function?
Auxiliary.
Basic function is something that is happening on the target.
Yeah.
So holds and moves are happening on the another component of the engineering system only. So they are auxiliary functions. So we're just labeling that. Informs is the additional function. Basic functions are only this. And basic functions are done by the toothpaste and by the bristles. All other functions are either additional or auxiliary. So if I want to now assign a function contribution to each of these components, what would that be? The handle has a functional contribution of 4. The head has a functional contribution of 2, and the bristles have a functional contribution of 5. Are you able to see this? So if you now want to remove something, what would you remove from the system? What could you remove?
The base.
We don't know that yet. No. We don't know that yet. Because what have we done? In our matrix, we just found where the different parts lie. We say, okay, the bristles lie somewhere here, anywhere on this row. Handle lies anywhere on this row. And the head lies anywhere on this row. We do not yet know if what is the cost involved there. So we can't say what to remove yet. We need to know what is the cost involved. And then we can remove something. We can decide to remove something. As of now, we are not in the position. Are you able to see this? Hello?
Yes.
So now what we are saying is we have kind of identified the steps for creating a function model. We say indicate a component, identify and indicate all the functions of the chosen component using the interaction matrix. Then determine and indicate the function ranks. Next step is determine and indicate the performance level of the function. For example, we could be saying that the performance of this removing function is excessive. Not only does the bristle remove plaque, it also removes the skin of the gums. So something needs to be done with the bristles. Or we could say that there is another component, gums and bristles also are interacting with them, this is an additional function and this is harmful. That it harms the gums. Are you able to see this? So we pick up a component, we see wherever there are the interactions, what are the functions involved there? And we do this for all the components then.